Welcome and hello. This is a support video in HEC ResSim. I'm titling this one Network Simulation Relationship. So we're going to be looking at how networks and simulations relate in a certain sense, as well as answer a question that one of my viewers sent into me asking why there's no flow through the uncontrolled outlet. All right, so what I have on the screen here is my HEC ResSim model that was sent to me. So it's not mine, but it's someone else's. And I'm using ResSim version 4.0 that just dropped last month in October 2025. So that's what I'm going to be using in this video. First, I'm going to go ahead and take a look at the results from the simulation, and then we'll dig into why there was no flow through the uncontrolled outlet, and then what we can do to force flow through the uncontrolled outlet. Right here is the reservoir, and I've already ran a simulation, so let's just go ahead and check out the results. I'm going to go right-click on the reservoir plot. This is going to bring a plot of the water surface elevation at the top, as well as the flow rates down below for the releases and the inflow. I'm going to zoom in on the water surface elevation. So this is a 12-month simulation. And it looks like the guide curve elevation is right here at 840.5. I'm going to zoom in one more time here. The water surface elevation here in green is 840.5, except for a little bit during the month of March, and again towards the end of the year where it's slightly above at 140.6 and a peak of 140.7. Okay, so keep that in mind. Let's go ahead and check out the release plots. So if I plot the releases, what we see here in green is the release from the controlled outlet. This is ranging from 0 up to 5 CMS. However, the blue line right here is 0 for the entire year. That means there's 0 release of water from the uncontrolled outlet. And that's because the invert of the uncontrolled outlet is 841, the maximum water surface elevation for this simulation is 840.7. We can go ahead and confirm those numbers by going and looking at the reservoir data. Here's that right here. If I click on controlled outlet, you can see that the max capacity is from 0 up to 5 CMS, starting at an elevation as low as 830. And then the uncontrolled outlet, the elevation, the lowest elevation where flow begins needs to exceed 841. Okay, so those are the numbers there. Should be no surprise why we have no flow out of the uncontrolled outlet. One way we could force flow through the uncontrolled outlet is to reduce the capacity of the controlled outlet. So I'm going to go ahead and just do that right here. Actually, what I am going to do is create a trial based on my original simulation. So I'm going to go right click, Alt 1, and then come down here to New Trial. I'm going to call this trial, name it Max 1 CMS. That's through the controlled outlet. I'll click OK. Now I need to actually make those edits. So I'm going to go right click on that trial of our first simulation called Alt 1. Go to Edit Run, click on Reservoirs, and then in the Physical tab for controlled outlet, I'll go ahead and change this 5 down to a 1. Okay, click Apply, click OK, click OK there. Now I want to run this simulation. And actually, one more thing I need to do because I just loaded this up for the first time is assign the proper inflow. So this is just a housekeeping measure here. Alternative editor. And actually, while I'm here, I don't need 15-minute time increment. That's a little bit too small for what's necessary. We'll just go with 1 day. And then for the time series data, I need to set that to the inflow data. So select DSS path to navigate to that file real quick. It's in RSS, and then it's in this simulation, and it's simulation.dss. That's the file. Inflow at CP1, set path. Okay, close that. We need to save this. It's made to the alternative. Click OK, and now we're ready to run. So right click and compute. This is basically the same simulation that was originally ran, except now the max release through the controlled outlet is 1 CMS. So instead of 5, let's just go ahead and do a right click and then plot the releases. Boom, this is now what we're seeing. In green, this is the release through the controlled outlet. You can see it maxes out at 1 CMS, or CMS. I may have said CFS. We're working with metric here. And then the blue line right here, this is the release through the uncontrolled outlet, which is no longer 0. It looks like it gets as high as about 11 or so CMS right here around the February, early March, as well as towards the end of the year. the second time. Now, one reason why this could be confusing and tying into the title of the video, which is the network simulation relationship, is because you may be tempted to go back to the reservoir network module and make an edit to the network, save the network, go back to the simulation module, run the simulation, and expect something new. But the problem is that the simulation that we created over here, this one, 2025 sim run, was based on the network before the change had been saved, the change of reducing the capacity through the controlled outlet. So I'll go ahead and demonstrate that. So if we go to simulation, reservoir networks, and say for instance, I want to modify this reservoir, I go right click, edit reservoir properties, and then I come to controlled outlet. I change that 5 CMS max capacity to 1, click OK, network, save the network. Then we go to the simulation module, and then I run the original simulation. So I need to set that as active, right click and compute. So that ran. Actually, it's taking a little bit longer because it's still based on the 15-minute time step. Okay, there we go. So that's done. Now, if we look at the results here, we should see 5 CMS flow through the controlled outlet. See, it's the same thing that we had originally. So the way around that, if you wanted to change the network and create a new simulation based on that changed network, we just go ahead and go back to our reservoir network module. We go network, and then, well, yeah, we could create a new network, or another thing we could do is create a new simulation based on this current network, which I already made the change to. So there's a lot of different ways to do it. Let's go ahead and do the latter. So I'll go to simulation, and I'll click on simulation, no. And then instead of calling this 2025 sim run, let's call it 2025 sim run 2, right? And then I'm going to just set the exact same start and end date times and look back at date time. Okay, so that those values have been set. Go ahead and select alternative 1 and okay. So that is ready to go. Hold on, looks like that there is an error. 1 second. All right, with all those changes made, we're ready to run the simulation. So I'll go edit, run. I changed it to simulation 3. I had to tweak something with the time step being changed to 24 hours instead of just 15 minutes. That way, over the course of a year, it's only going to be about 365 time periods instead of 35,000 or whatever. All right, so what am I doing? Right click, compute. That ran. Let's go ahead and check out the results. So I'm going to right click on the reservoir. Let's go straight to plot releases. And boom, here are the same releases we saw when we reduced the capacity through the controlled outlet from 5 CMS down to 1 CMS. We have the exact same results as before, where the controlled outlet release looks to be have a ceiling of 1 CMS, and then the uncontrolled that looks like it's up above 10 CMS right here in early March. We can also look at the actual numbers. We're going File and Tabulate. Here is a table of values here. So each row in this table is a different time period. I'm doing 1 per day here. This is the controlled outlet right here. The second column is LNO. And then the third column here is the uncontrolled outlet, which we should see some numbers right here after about a couple months into the simulation. All right. Well, that's it for this support video. What we did was we took a look at an existing model that was sent to me where the user was a little confused why there was no release from the uncontrolled outlet. We got that problem settled, and we also explored the relationship between the network and the simulation.